Ladies and gentlemen, welcome to Advanced Infrastructure for fiber optics in the city of Philadelphia and the benefits that will provide. My name is George Lang. I'm a MBA in Technology Management, former employee of Comcast, and I very much appreciate you all coming here tonight. So today's agenda is to provide Philadelphia with a wonderful opportunity to catch up, believe it or not, to South Korea and Japan, and improve our ability to compete globally with an infrastructure in Philadelphia, and in Philadelphia alone. And by that I mean, there are very few cities that have, in fact, there are no cities that have done this already. Entire cities the size of Philadelphia. Baltimore, as a matter of fact, is completely devoid of any fiber optic infrastructure. And I'll explain why fiber optics is important in a second. The agenda for today includes and I hope we can all see that, Verizon and Comcast as the status of telecommunications in the city of Philadelphia right now and the surrounding region is there's only two providers basically of broadband, Verizon and Comcast. So there's a competition, but it wouldn't be considered a perfect competition because that you only have two providers, and they're huge. They're both very huge, but we're speaking locally here, and Verizon and Comcast are the only two that are providing it. We're going to talk a little bit about in a second about why fiber optic is important to the future of Philadelphia in particular and our country as well. Shared housing infrastructure is an important topic, and I'll get into that in a minute. The importance of how this plan, and we're going to provide an action plan at the end of this for local unemployment situation, which is extremely high, particularly in Pennsylvania, over 10%, and especially in the city of Philadelphia. Why the role of government is valuable in this particular case, and then we're going to cover a few of the challenges for the future. So let's start by describing the status of fiber optics in the city of Philadelphia and broadband in general. The backbone of communications infrastructure in the Philadelphia area is largely fiber already. In fact, fiber's been installed since the early 1980s. 1980, my father was installing fiber optics for Western Electric division of AT&T back then, before the breakup. He was installing it in Wayne, in the area of Wayne, Pennsylvania. So fiber optics is not something new. It's 30 years old. It has been installed for 30 years, and it is now in place, believe it or not, for both Comcast and Verizon. Most people think Verizon is the only one that has fiber optics because of Fios, but it's not. Comcast also uses a fiber optic backbone, and that's the backbone. That's not to the house. That's from the stations to the street and through the streets. Comcast is behind on that as well. Pardon me. Verizon is the only one who, like I said, is bringing fiber optic to the house itself. Now, they do this in two ways. They either bring this, and it's very expensive for them to do this. They've spent $23 billion over the past 6 years, since 2004, in installing this system, 6 or 7 years. Over $23 billion to install this. So they're having trouble competing with Comcast, and they've actually started to slow the rate of that rollout. When you do an underground installation, it's a 3-man job. It takes 2 days. These are neighborhoods where there's no overhead utilities, In the areas where there is overhead utilities, it's a two-man job for one day to bring fiber optics to the house, and that's what Verizon has been doing, is investing an enormous amount of money in that. Now they've slowed that because they're finding it hard to compete with Comcast, and the Comcast is just bringing in coaxial cable to their houses, and it's much cheaper for them to do that, and the hardware involved for Verizon is much more expensive as well, and much less expensive for Comcast. So they're finding it difficult, and they're slowing the rollout. That's not good for the city of Philadelphia, and Japan and South Korea have already made these investments. If we're going to compete globally, I think this is an excellent opportunity for Philadelphia to become a bellwether city, and to take the initiative, government-led initiative, to force this to happen, and I'll explain that in a second. Fiber optic is going to be coming to every house soon, regardless, and I'll explain that. Dean has provided in his book Network Plus, a guide to networks. Professor Dean from Boston provides some data for us. Why is fiber optics important? The bandwidth is 10,000 times faster than cable, coax cable, which is being used by Comcast. Right now, the differences are really not that great because of the way it's being distributed. But ultimately down the road, there's going to be a huge difference. And this is why houses are going to have fiber optic not only to their house, but within their house. Okay, right now, nobody has fiber optics within their house. Only businesses have fiber optics within their establishments, and this is because they use video conferencing, streaming video, training videos, all kinds of things. And video is a very bandwidth-intensive thing. So businesses, large businesses, enterprises are the only ones using this at this point. But ultimately, it's going to be used in the houses because it's virtually unlimited bandwidth with fiber optics. And the way fiber optics works is using light, and I'll show the importance of that in a second. Copper UTP, unshielded twisted pair, copper, like Cat5, Cat6 cable has a bandwidth of a billion bits per second. Even that is nothing, and this is why your networks inside your house ultimately are going to be run in fiber. People are going to stop running copper because of this. Bandwidth is 100 billion bits per second, much faster. So the benefits of that are you have no electromagnetic interference, EMI interference, like you have with electrical metal, copper wiring. So the interference and the crosstalk is much less in a fiber optic system. The digital data is much clearer, much better. The distances that can be run. Fiber optic cable can be run in the distances of miles. When you're talking about copper UTP is 100 meters limit, 100 meter limit. With coax, it's a 500 meter limit. That's what's being used by Comcast. Fiber optic can be run miles, 40,000 meters limit. Okay, video conferencing, and I am trying to persuade you, by the way, with this. I guess you've noticed.